Okay, this is Dr. Williamson. I kind of came up with a problem that I want to solve for you to show you a handy little trick. Okay, so here in this problem, it says how many kilograms of AlOH3, which means AlOH3 with a subscript 3. So this is what it really is right over here, are made when 2.75 kilograms. Oh gosh, kilograms. Okay, of Al2S3. That's this thing, Al2S3. That looks kind of like a 5, but that's an S. The 2 and the 3 are supposed to be subscripts. When I type it, this app that I'm using doesn't let me do that. It says when 2.75 kilograms of Al2S3 is reacted with excess water in the following chemical equation. So that means that in this problem, I'm going to be working with this piece and this piece. And when it says that the water is excess, that means I'm not using the water for my calculations. So I cross it out so I can like mentally, I mean, it's still there, but I kind of use it to kind of mentally remind myself not to get confused by it. And also, since I'm calculating for aluminum hydroxide, I can, for this problem, ignore that. They're still there, but I can ignore them. And this is 150.158 grams per mole. That's its molar mass. And I looked this up. This is 70.004 grams per mole. But this is in kilograms. Let me show you a neat little trick. Okay. And I want you to learn this trick. Okay. So 150.158 grams per mole is the same thing as 150.158 kilograms per 1 kilomole. When I convert this into kilograms, 150.158, I divide by 1,000. So I can do here 150.158 grams times 1 kilogram is 1,000 grams. So I'd be dividing by 1,000. But I can take 1 mole, right? Because this is 150.158 grams per 1 mole. And 1 kilomole is 1,000 moles. Guess what? When I do that, the thousands here cancel out, as do the moles and the grams. So 150.158 grams per mole is the same thing as 150.158 kilograms per kilomole. It's also the same thing as 150.158 centigrams per centimole. If I was going to do that, it's kind of like the K's cancel out with each other. So I've got here, I can do this. I'm going to go ahead and solve this now. I've got here 2.75 kilograms of Al2S3 times 1 kilomole of Al2S3 is 150.158 kilograms of Al2S3. And guess what? by the same reasoning, 1 kilomole of Al2S3, remember there's an invisible understood one here, will give me 2 kilomoles of AlOH3, because again, the kilos kind of cancel out. So you end up with the same ratio, because to turn the moles of AlOH3 into kilomoles, I divide by 1,000, but I divide by 1,000 down here, just like I did kind of over here. And so that works. And then 1 kilomole of AlOH3 is equal to 78. I'm a little clumsy today. 78.004 kilograms of the aluminum hydroxide. So here, kilograms of this, kilograms cancel with kilograms. And this is supposed to be, I made a typo mistake here. This is kilomole, right? And 1 kilomole of Al2S3 cancels with kilomoles of Al2S3, and kilomoles here of aluminum hydroxide cancel with kilomoles of aluminum hydroxide. And I'm going to have 2.75. This is 3 sig figs. This is exact. This is 6 sig figs. Both of these are exact. This is exact. And this is 1, 2, 3, 4. This is 5 sig figs. So when I punch this into my calculator, 2.75 times 1 divided by 150.158 times 2 divided by 1 times 78.004. And I will get here equals 2 point, and I have to round it to 3 sig figs, 2.86, make sure that decimal point is clear, kilograms of AlOH3 will be my answer. And let me box that, kind of make it a little bit clearer. That will be my answer. Now, this trick might seem confusing, but let's look at this again. I had 150.158 sloppily written. That's 150.158 grams. If I want to turn that into kilograms, I'd go 1 kilogram divided by 1,000 grams. So I'm dividing the 150.158 by 1,000 grams. But if I also convert the moles into kilomoles, I'd multiply 1 kilomole over 1,000 moles. I would end up dividing here by 1,000. So I'm dividing up here by 1,000, but I'm dividing down here by 1,000. I'll find out when I'm done that as long as I do the same to both, 150.158 kilograms is 1 kilomole for this molar mass. If I look here let me erase that. Let me go to the eraser. I'm going to erase this. You guys can, rewind. Okay. If I look here, draw, and I'll do it in blue. For every 1 mole of this, I get 2 moles of that. So I'll write 2 moles of Al OH3 OH3 for 1 mole of Al2, that's supposed to be a 2, S3, but if I want to turn the moles into kilomoles, you'll see that it makes things easier. 1 kilomole is 1,000 moles. And down here, 1 kilomole is 1,000 moles. And I ended up dividing by 1,000 on both the top and the bottom. And the dividing by 1,000 cancels out, and the mole part cancels out. And I will end up with this right here. Oops. I'll end up with this piece right here, where 1 kilomole of Al2S3 is 2 kilomoles of that. I could also say 1 millimole of Al2S3 is 2 millimoles of that. The process works the same. So that'll save you having to go 2.75 kilograms, converting the kilograms into grams, and then solving it the regular way, getting your answer in grams, and dividing again by 1,000 to turn it into kilograms. I just realize that as long as I do the same to top and bottom, 150.158 megagrams per 1 megamole, that works. And I could say 2 megamoles of this for every 1 megamole of that, or I could do kilomoles or whatever. Anyway, I hope this little trick helped. If you work through it slowly, you'll see that it really speeds things up. You get the same answer, and it will save you a lot of time. Okay, I hope that helps.